Adjunct Professor Moran, Microeconomics 112. We're going to conclude our discussion of the demand for resources by considering a two-input problem. Up until now, we've only had one input, and the decision rule was marginal revenue product equals marginal resource cost. Continue to hire a resource as long as it contributes more to revenue than the resource costs. The resource cost is assumed to be constant because they're going to be hiring in a perfectly competitive labor market, and they're selling a perfectly competitive output market, so price and wage are constant. But the amount of revenue contributed by each additional input will vary because of the principle of diminishing marginal returns, which is as you add additional units of variable input to a fixed plant capacity, output will go up at a faster pace, and then it will go up at a slower pace, and then it will turn negative. So here we're going to consider a different problem with two inputs, in our example, labor and capital. And we have to have a new decision rule in order to decide on the optimal amounts. There are two types of problems that can occur when there are two inputs. One, produce a certain amount at a minimum cost, or two, produce any amount and maximize profits. Why wouldn't you always want to maximize profits? Suppose, for example, you maximize profits at 100 units of output, but you can't sell 100 units of output, and you can only produce 70 units of, you can only sell 70 units. So you would want to produce those 70 units at a minimum of cost, and later, if you could eventually sell the 100 units of output, then you go ahead and go profit maximization. But that's why you would choose cost minimization over profit maximization. To produce some certain amount to minimize costs, we're going to apply the least cost rule. The last dollar spent on each resource yields the same marginal product. So you're going to take the marginal product of labor, how much extra output does the next unit of labor produce, divided by the price of labor. And then you're going to take the marginal product of capital, how much extra did that next machine contribute in terms of product, divided by the price of capital. If the marginal product of labor divided by its price is greater than the marginal product of capital divided by its price, then you would want to use more labor. You're getting a larger bang for your buck. Because of the principle of diminishing marginal returns, as you do that, the marginal product of labor divided by the price of labor will fall and eventually come into equality with the marginal product of capital divided by the price of capital, and there would be no reason to substitute between more labor or more capital. Again, you're going to keep choosing the one for which you get the biggest bang. As you hire an additional laborer, his marginal product will change. Divide that extra product by the price. Compare it to the marginal product of capital. When you add an additional machine, how much extra product that produce, divided by its price. For which one are you getting more bang for your buck? Which one are you getting the better deal? More product per price of labor or more product per price of capital? The one that's larger, use more of that until they're equal. The profit maximizing rule is when you do the same ratio, but it just comes out to equal 1. So let's begin and do each type of problem. So here's our table, and what we need to do is build our table such that we have the columns that are required to apply our decision rule. So in a cost minimization, we know that we need the marginal revenue product of capital divided by the price of capital equals the marginal revenue product of labor divided by price of labor. And they have to be equal at some amount of output. So we need to build this table out until we have this for each capital and labor. We're given the quantity of input, capital and labor, and we're given the marginal physical product. We could have been given the total product and subtracted to get the marginal physical product, but instead we're given the marginal physical product, and we're going to calculate the total product. The marginal physical product of capital is if you hire an additional machine, how much extra output do you get? The marginal physical product of labor is, as you hire additional workers, how much extra output do you get? Marginal, extra, or change. Notice these numbers are going down because of the principle of diminishing marginal returns. Okay, so now let's start calculating our total product of capital. Hire one machine, you get 24 output. Two machines, you get an extra 21, which gives you 45 total. Your third machine contributes an extra 18, which gives you 63. Your fourth contributes an extra 15 units of output, giving you a total product of 78. Your fifth machine, you notice that your total, you get extra 9, which gives you a total product of 87. You hire your sixth machine, and you get 6 extra units of output, which gives you a total product of 93. 3 more is 96, 1 more is 97. What's your total revenue? In this problem, you're going to be able to sell your product at $1 each. Each machine costs $3. Your total revenue is total product times the price of the output. So these columns look the same because the price of the output is $1. But if the price of the output were $2, you'd have to multiply this column by 2. So don't be fooled by that. Okay, these are dollars. This is number of product. Okay. Price times quantity of output. Let's do the same for labor. You hire your first worker, you have 11 units of output. You hire your second worker, you have 9 more, you have 20 total. Your third worker contributes an extra or marginal 8, you have 28 total output. 7 gives you 35, 6 more gives you 41. Your sixth worker contributes an extra 4, your total product is 45. 7 workers gives you an extra 1, and you have 46, and this guy at a half, you have 46.5. Now let's figure out marginal revenue. Well, marginal revenue is the change in total revenue, marginal revenue product is the change in total revenue given the change in number of workers. If you just say marginal revenue, it's assumed how much extra revenue you get by selling 1 more unit of output. But marginal revenue product is how much extra revenue you get by hiring 1 more input. An important distinction. If you remember marginal revenue from our discussion on types of business competition, we're now discussing the demand for resources. So marginal revenue product, how much extra revenue do you get by employing 1 more input. Okay, subtracting 24 from 0, you get 24. 45 minus 24. And this column and this column look the same. This column and this column look the same because the thing is only selling for $1. So it would have been a better problem if they changed that to make it some different amounts. It really made the difference between these columns explicit. But these are dollars. These are numbers of boxes falling off the assembly line. 78 minus 63. 87 minus 78. Calculate total revenue for labor. 11 total product for 1 worker selling each product at $1 is 11. 41 times $1, 45 times $1, selling these things for $1. Products, dollars. Marginal revenue, 11 minus 0 is 11. 20 minus 11 is 9. And again, you'd have to divide this by the change in output if this is anything other than 1. So again, they're masking that in this problem. Subtract marginal product. Marginal always is the difference between 2 rows. It's a change from 1 row to the next. Okay, now we have our marginal revenue product and we have our price. We can now calculate the marginal revenue product divided by price, and this is labor. Okay. Since the thing sells for $1, the price of capital is $3. So 24 divided by 3 gives you 8. 21 divided by 3 is 7. 18 divided by 3 is 6. 5 divided by 3 is 5. 3, 2, 1, 1/3. This is your marginal revenue product of capital divided by the price of capital. How much extra revenue did each machine in turn contribute divided by the cost of that machine, which is constant at 3. The price of labor is 1. So 11 divided by 1, 9, 8, 7 divided by 1. Okay. Now, The boss comes in and says we need to produce 80. We can't produce profit max. We can't sell that much. So we know we can sell 80. We want to produce 80 with the combination of capital and labor such that our costs are minimized. The decision rule is just find any combination of output that gives you 80, combining capital and labor, such that the marginal revenue product of capital divided by the price of capital equals the marginal revenue product of labor divided by the price of labor. If they're not equal, you're getting a bigger bang from one than the other, and you should substitute between the two until, because of the diminishing marginal product, you get an equal number. So we need to combine 8 and 8 does not give us 80 output. 7 and 7 is 45 and 35. That gives us 80 output, and the numbers are equal. So the quantity of capital that will be used is 2 machines. The quantity of labor is 4 laborers. The total revenue from employing capital will be 45. The total revenue from employing 7 workers is 35. Your total revenue will equal 80 since the thing is selling for $1. Your total cost of employing machinery interesting, we don't have that. 3 times 2 machines is 6. Right? We have 2 machines, and they're $3 each. We have 7 laborers. We have 4 laborers. That's $10. Our total cost, and so our profit is 70. Okay. Now let's say the boss comes in and says, okay, now we want to profit maximize. Okay. Now we need to figure out the combination of capital and labor that will, regardless of how much output is going to result, will maximize our profit. The decision rule for this is changing. It's this rule still, but here, where this was 7 and 7, we're now looking for 1. And here it is. This one is just that simple. Find the marginal revenue product of capital divided by the price of capital equal 1. Find the marginal revenue product of labor divided by the price of labor such that that's equal 1. And now we have the profit maximizing combination. To profit maximize, we're going to hire 7 machines and 7 laborers. That's a coincidence. That does not have to be equal, the number of machines. The total revenue from machinery is 96. The total revenue from labor is 46, giving us a total of $142. The quantity of machinery is going to be, quantity of input is 7 and 7, sorry. This is quantity of output. Quantity of output at 7 machines is 96. Yeah, these things are selling for $1, so these columns look alike. So 96 times $1 is 96 total revenue. 46 output from labor times the price of $1 gives you 46. 96 and 46 gives you total revenue of 142. You're using 7 of each. A machine costs 3. 7 machines at $3 each gives you total cost of machinery of 21. Labor is only costing $1. 7 laborers at $1 is 7. Total cost of 28. Okay, your total profit from machinery is total revenue minus total cost, 75. Total revenue from labor minus cost of labor of 7 gives you a profit from labor of 39, and your total profit would be $114. This should crossfoot. Always crossfoot your numbers this way and this way to check that they equal. Oftentimes you do a spreadsheet and you'll build a spreadsheet in Excel and you get this number by building it one way and you don't realize it's not tying the other way. So always have a box out here someplace where you can add it down and then add it across, make sure the numbers are equal. So this is the profit maximizing level of output in a two-variable problem. Applying the rule marginal revenue product of capital equals the price of capital equals 1 equals the marginal revenue product of labor divided by the price of labor equals 1. Profit maximization. The first part we did was cost minimization, where it doesn't equal 1, but they do equal and give you a quantity that is desired. And when you do that, get the quantity combined where these numbers are equal, then you have cost minimization at that level of output. In our next chapter, we're going to discuss actual wage determination. We've discussed the demand for resources. It's the marginal revenue product of each. This is the demand for capital. This is the demand for labor. Well, in the next chapter, we'll add supply and determine the prevailing wage rate.